Good day, everyone, and you are once again welcome to Justified series. My name is Justified, and I'm the CEO of Justified Tutors Academy. Now, today, our focus for today is what? Mathematics. Are you getting me? We are going to be focusing on what? On mathematics. Now, before we begin, I would like to say some things. If this is the first time you are watching my video, or the first time you are coming across my video, do well to like this video, comment on this video, and what? Share. Now, comment when you have questions, but always what? Share this video with all of your friends. Now, this video is for anybody that is what? That is preparing for what? For WAEC. Whichever time you are watching this video is what? Is very, very important for you. And today, we are focusing on what? On mathematics, ahead of what? The mathematics exam coming up on Wednesday. That is the 3rd of June. Are you getting me? Now, listen again. This is the part 3. We have part 1, part 2. So if there are some things like now in this video now, there are some things that I'm going to be talking about, and there are some things I will not be talking about because of I've already done them in part 1 and part 2. So if you are looking for topics like bearing, long-term latitude, and many more, please go and check part 1 and part 2. You get me? I've already covered those topics in those parts. Are you getting me? So now, today, I want to give you guys the list of topics that will surely come out in your exam on Wednesday. Are you getting me? I want to give you the topics that you will surely see them in your examination. Are you getting me? So, in part 1, I already talked about some topics. But right now, today, I want to add more. Do you get me? I want to add more topics. Or I want to talk about the game so that those that are just in for the first time can be able to note what I'm saying. Are you getting me? So now, I want to get your pen and biro and follow me very carefully, because in this video you need to have your pen and your book. Are you getting me? So let's begin. So now, the first topic that you surely see on Wednesday in your math theory exam is what? Okay, let me label it as number 1. Come in. Let me call it number 1. The first topic that will come out on Wednesday is what? Is set. Now, this particular topic, in the past 5 years, it has come out 3 times, including last year. Yes, it came out last year. Set. So I'm sure this one will come outside. Are you getting me? So this one is 3 times. So do well to revise it. The next one is what? Profit and loss. Profit and loss. Now, this topic in the past 5 years came out 9 times. The next topic is what? Subject of the formula. Subject of the formula. Now, this one in the past 5 years, it came out 2 times. And that is what? 2020 and what? And last year. So, master this one. We've already done this one in part 1 and part 2 already. So you get same thing with this one, except this one. So go and master them. Just go and do your revision, so that you'll be ready for for Wednesday. Now the next one is what? The next topic I have here is simplification. Now, simplification is not a topic on its own. Are you getting me? It's just it comes in this format. They can ask you to simplify something. You get, maybe simplify this. You get, but just so that you surely see something on simplification. So you should know how to simplify things to their lowest term. Are you getting me? Now the next topic. Now this one in the past 5 years, yes, it has come out 5 times. Yes, in the past 5 years we've seen simplification come out every single year. Are you getting me? Now the 5th topic I have here is what? Is shapes and angles. Shapes and angles. Shapes and angles. And this particular topic, in the past 5 years, it has come out 8 times. 8 times. So there is an high possibility that this year you usually see a question on what, on shapes and angles. Now let me give you an example of this one. You see when they ask to find the angle in a triangle. That's this one. Maybe isosceles triangle and other stuff. That's under this topic. Or they say you find the perimeter of something, find the area of a particular shape. Is this one. So you get now. So that's an example. Now the next one is what? The next topic is what? Is volumes of solid. Volumes of solid. Now, this topic, in the past 5 years, it has come out what? 6 times. Now, it doesn't come out every year. But when it comes out, it comes out what? Heavy. And most times, they always ask to find what? Either the volume of a cylinder, the volume of what? Of an hemisphere, the volume of a sphere, the volume of what? Of the volume of a cone. So you get, those are the kind of questions you see under this particular topic. Also, you can also see under the topic, you can see questions like find the surface area. So you get of a cylinder. Same topic as well. So you get, so go and practice them. They will surely come out, and it's not at all. Just know the formula to use, and they are good to go. Now, this next topic, number 7, is what? The one and only that you can never escape it. Probability. Probability. And this one has come out what? 8 times. Now, moving on, the next topic has come out that I am sure that will come out is what? Is graph. See, I'm coming. You see, if you like, go and collect breeze from Baba, or you collect white powder from Baba, anyhow you want to do this graph will surely come out. And we have 3 types of graph. We have the quadratic graph, we have the trigonometric graph, then we have one more graph. What's the name, Sha? But the one that comes out every year are your what? Your quadratic graph and your what? Your trigonometric graph. So you get, so go and master them because they always carry mark. I think the least mark I've seen this one carry is 20-25 marks. So go and master it. I get me. It's very, very simple. This one, if you can do it alone, you've answered one full question. So this one will come out like, okay, so now out of the first 8 I've written here now, the one I'm sure that will come out is this, 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 this. You see them? All those I'm putting out now, you will see them in your exam on Wednesday. Are you getting me? So just take note of them. But the others can come out or might come out because of looking at the trend. They've always what come out. You get, and this one now can be like question 1A. Are you getting me? Question 1A, question 1B. You get question 2A, question 2B. You grab question 3A. You grab question 3B. But this one, you know they get 3 or 3B. Now like question 7, the whole question 7, now graph. All right, now follow me. Sorry. Follow me to the next part. Please write this down and take note of it so that I can what, to know how to do your revision or to know the topics to focus on. So now, moving on to the next one. Let me quickly rub this off. The next topic I have here is quadratic word problem. Number 9. Quadratic word problem. Let me divide it safe. Quadratic word problem. Now, this one, in the past 5 years, it has come out what? 3 times. So, you're not really sure like that. Because of most times, okay, let me just add number 11. Sorry, number 10. That's a word problem. So now, this one now has come out how many times? 3 times. Now, let me explain this to you. You see, word problems always come out in every single WAEC examination. Are you getting me? Yes. Now, you see, just that it can either be a word problem leading to a quadratic equation or a word problem leading to what? A simultaneous equation. Are you getting me? Yes, it can just be any of them, but just know that what there will be a question on what problem. So just note that down. That's why I put 3x and 3x so that you can know how in the past 5 years how it's. But normally it's meant to be 6x, but I have to break it down for you so that you can know the difference. We have quadratic word problem, that is word problems leading to what quadratic equations. I did that in part 2. Go and watch it. And then what word problems leading to what simultaneous equation. Are you with me? Now let's move on. Number 11 now. Number 11, we have AP and GP. AP and GP. I'll be dropping a video on this tomorrow. AP and GP, which is Tuesday. Yes, I'll drop a video on this tomorrow. So AP and GP. This one has come out what 4 times. So you get. I'm just going to revise it because of I'm having a feeling that it will come out on Wednesday. But then still a probability it might not come out. But you must know it. Now, number 12 is what? Bearing and distance. Bearing and distance. Now, you see, this topic in the past 5 years, it has come out 6 times. In the past 5 years, it has come out. That means one question at least a year. I get me. That means in the past 5 years, we've had bearing and distance. Just that in 1 year, it came out twice. Yes, you cannot escape that one. That's why in my part 1 video, I touched bearing and distance. And in my part 2 video, I touched bearing and distance. Because of it will surely come out. You cannot escape that touch. You get. And sometimes it can come as a little question. And sometimes it can come out in a bulky format. So please guys, go and revise bearing and distance. In fact, my channel, this YouTube channel, is filled up of what? Of bearing and distance. The first video I dropped on this channel is a teaching on what? On bearing and distance. So just go there and watch it quickly. I get me. Now the next topic is what? Is number 13. And that's what? Cumulative frequency. Let me just write this for you guys. Cumulative frequency. Cumulative frequency. Now, you might be wondering, sir, why are you adding this topic? This topic has come out only once. Only once. And that once was last year. Are you getting me? It came out once last year. So I'm adding it because of WAEC can decide to bring that again this year. Are you getting me? They can decide to bring that again this year. That's why I'm adding it. Are you getting me? So now, the next topic now. Okay, so now the next topic, which is number 14, is what? Is equation of a line. This one, it doesn't come out every year. But then, in the past 5 years, it has come out what? 5 times. Yes, 5 times. You can see, because in some years, you can have like 2 questions on it. So just master equation of a line. Just revise it. It won't take time at all. Question 15, number 15 is what? Simple interest. Simple interest is similar to what? To profit and loss. So what they do is that if you don't see simple interest question, you see a question on what? On profit and loss. And if you don't see profit and loss, you will see what? Simple interest. That is how WAEC is to what? Alternate it. So you get. That is why you must revise simple interest. At the same time, still what? Revise profit and loss. Now, let's move on. Number 16 now. The 16th topic that I'm sure that might come out on what? On Wednesday. Is what? Distance and time. This one for the past 3 years now, they've been bringing it out. So therefore, this year, there is a very high probability that it will come out. Are you getting me? So please, take that down. Now, and in the past 5 years, it has come out what? 4 times. These 4 times started what? In the year 2023. Are you getting me? So it might come out again this year. That's why I'm adding it to it. So you get. It's just things about distance and time, velocity and all that. So just go and do your revision on it. Now, the 17th topic is this. Angle of elevation and depression. Angle of what? Of elevation and depression. Now, this topic is under bearing and distance. Are you getting me? This topic is under bearing and distance. So, most times, if you don't see this one, you will see this one. And you can see both of them. So, please, guys, go and revise this one. Angle of what? Elevation and depression. So you get, so that you don't get shocked in the examination hall. Are you getting me? Now, the next one I have here is number 18. And it is what? Variation. Variation. I already talked about this one in my last video. So you get, it's not really important, but then it's good you know it. And that's why I thought it was in my last video. So go and watch it. Now, topic 19. This one in the past 5 years, it has come out 4 times. Yes, 4 times. And most times, it's always what's under this one. That means this will be like question 2A, 2B. Then we have done as 2C. Are you getting me? So now, number 19. Now, the 19th topic is what is factorization. Factorization. And this one has come out many times. It has come out just once. No, not once. So it's 3 times. 3 times, yes. And it came out last year. Yes, it came out last year. It came out last year. So that's why I'm adding it, because of that WAEC, they might bring out what this particular topic. So please, guys, go and revise it. How to factorize? Yes. Now, I will detect the rest. Oh, okay. Number 20. Let's move on. Number 20. I'll be faster now. The 20th topic I have here is what is logarithms. Yes. The 21st topic I have here is what is longitudes and what? Latitudes. Longitudes and what? Latitude. 22 is what? 22 is what? Is mean, median, mode, variance, and standard deviation. So go and master all those stuff. I think we call it a measure of dispersion. Measure of something and dispersion. Then the 23rd one is what? Is number base. The 24th one is what? Polygon. And then the particular topic that I can beat my chest that you will see it on Wednesday is the topic that I want to focus today, which is the Baba of the Baba of the Baba. Yes. And that topic is what? Is number 26. The name of that topic, let me clean the board because of we are going straight into the topic. Yes. So let me rub up the board. Please write down what I've given you guys. So you get, write it down and then share with your friends so that they can know as well. You guys can do that group revision or whatever. Just do it to revise. Now, the 26th topic that has come out 17 times in the past 5 years, like 17 times in the past 5 years, is what? Circle Theorem. Circle Theorem. This topic has come out what? 17 times in the past what? 5 years. Imagine 17 times in a particular year. You can have like 3-4 questions on Circle Theorem. 3-4. Yes, you heard that right. 3-4. And that is the focus for today. So that at least if you see 3-4 questions on this one tomorrow, you already gotten what? Your mark. Then plus bearing, plus probability, plus variation. So you get, So today, guys, our focus for today is what? Is Circle Theorem. Now, I would like you to what? To pay attention today because of it is very, very important. Because this Circle Theorem is very, very confusing. It's broad. So no matter how long this video is, I want you to what? To sit down and watch it to the end. I get it, because of this topic might be your lifesaver in that examination. Or now, ladies and gentlemen, let's begin. Now, the first thing under what Circle Theorem is what? Is the theorems. You must know the theorems. Now, let me break it down for you. Circle Theorem is divided into 2 parts. We have the part whereby we have the where we talk about what? The length of an arc. Let me put it like this. We have where we talk about what? The length of arc. You get. We have where we talk about what? The length of a chord. We have where we talk about what? The length of a segment. The length of what? Of length of segment. The one again. Length of forgotten again. So that part is one part on what? On circle geometry. But our focus for today, that is the one I want to teach you guys, is either a triangle in a circle or a circle in a triangle. That is the major one on what? On circle what? On circle geometry. Now, start writing. The first theorem, number 1. The first theorem is what? Is angle at a center. Now, angle at a center. I'm going to dictate what I have here for you guys. Now, angle at the center. The angle at the center of a circle is twice the angle at the circumference standing on the same what? Arc. Now, let me draw how this particular one is to look like. Let me draw it for you. This is how it looks like. There will be a circle like this, right? Then there will be a triangle inside like this, right? This is the point here. So you see, the angle at the center, which is here. Let's say here is the angle at the center. The angle at the center. The angle at the center is 2 times the angle here. Are you getting me? The angle at the center is what? Is twice the angle what? At the circumference. She gets. So if here is theta, here will be what? Will be 2 theta. That is the first rule. It means that what? If we have 20 here, here will be what? Will be 40. That's what? Angle at the center. That's the first theorem. Write that down. Because of after this one, we'll be taking question on it. Are you getting me? That is the first part. Let me clean it off. Please, if I'm too fast, always go back, pause and what? Jot down and what? Follow me. Now the second theorem. The second theorem is angle in a semicircle. Angle in a semicircle. Now, the angle in a semicircle, the angle formed by a diameter at the circumference is always what? 90 degrees. She gets. So, whenever a triangle is drawn inside a circle with one side as a diameter, that particular triangle is always what? Equal to 90 degrees. Now, let me draw it for you so you can see what I'm talking about. So, this is a circle here like this. Right? We have one side come down here. Our middle point is here. Then we have go like this. Yes, then you join like this. So, this particular triangle is always what? Equal to 90 degrees. So, the angle in this particular triangle, this particular triangle is what? Is equal to 90 degrees. The angle in what? In a semicircle. That means everything here has to what? Be equal to what? To 90 degrees. Now, let's move on. Let's move on. Because we'll touch question on that aspect too. Alright. So now, the next part, the next theorem I want you to note down is what? Is angle in the same segment. Number 3. Angles in the same segment. Angles in the same segment. Are we together? Angles in the same segment. Now, angles subtended by the same chord or arc at the circumference are equal. Now, let me show you what this means. Let me show you what this means. We have a circle here, right? Then we have our first line drawn down here. We have another one going like this. We have another one going like this. We have another one going like this. Now, see clearly, the meaning of what? Of angles in the same segment are equal is that the angle here, if it is x, it is equal to what? The angle here. And the angle here, if it is y, it is equal to what? The angle here. That is the meaning. All these things are very, very important. Are you getting me? Yes, they are important. Because of that is what you use to decode a particular question. Now, follow me carefully. Still on circle theorems. Theorem 4. Theorem 4. Let's move on. Theorem 4. Theorem 4. Now, Theorem 4 says cyclic quadrilateral theorem. Cyclic quadrilateral theorem. Cyclic quadrilateral theorem. All right. Cyclic quadrilateral theorem. Now, what this means is that what the angles of a quadrilateral inscribed in a circle add up to 180 degrees. Now, what does this mean? It means that what when you have a circle like this, right, a big circle, and then you have what a quadrilateral inside it like this, right? The angle at this point is equal to what? The angle at this point. Sorry, not equal. The angle at this point plus the angle at this point is equal to what? 180. So let's say here is what is A and here is B. Therefore, A plus B will be equal to what? 180. Do you get it now? That's basically what it means. Now, let's move on. Let's move on. Okay, so now the next one is what? Is perpendicular from the center to a chord. Okay, so let me rub this off. Angle that is what? Perpendicular from the center to a chord. Number 5. Perpendicular from the center towards a chord. I guess this marker is gone already. Let me drop it. Thank you. So now let's launch our new marker. All right, so let's go. So now, before we launch the marker, let's write this down. Now, when you say perpendicular from the center to a chord, what this means is that what a line drawn from the center of a circle perpendicular to a chord bisects the chord. You get? That means it will cut the chord. And when it cuts the chord, it basically means that what I'm coming. Let me just draw a circle and label it first. So we have a circle here, right? Then we have yes, we have something here like this. We have our middle line here. Get me? So now this is what is bisecting it. This is the bisector. I get me? This is the bisector. So now let's go back to the statement again. A line drawn from the center of a circle perpendicular to a chord. She get? Cut it into 2 equal parts. She get? Now, let's say our this thing here is what we have here A, we have here to be what? To be B, and here to be C. Now, you see, what if you have kind of what this kind of circle, she gets the question. What this means that what is that this place is equal to this place. I get me. This place is equal to what? This place. That is what this particular rule is talking about. So guys, write it down. Write it down. Hey, don't fold, Joe. Don't fold. So now, let's take rule number 6. Rule number 6. We are moving fast. I like that. Let's take the 6th rule here. The 6th rule is what? Is radius and tangent theorem. 6. Radius and what? Tangent theorem. Radius and what? And tangent theorem. Now, what does this rule say? It says that what? The radius is always perpendicular to what? The tangent at the point of what? Of contact. Now, let me give you guys what? The diagram. We have a circle. This theorem tells you that what? You have something here like this. You get? We have the center. So now the angle between what? A tangent and the radius at what? At the point where the tangent touches the circle. So you get? This is with the tangent here. At the point where the tangent is touching the circle, so you get? Is what? A right angle. That means the particular triangle in this side is what is always equal to what? 90 degree. Are you getting me? So when it's something like this, it did not tell you. Just know that what this particular point is what is 90 degree. That is what the 6th theorem. Now we're almost done. We're going to what the 7th one now. But then let me see the end of that thing to get again. Okay, that's all. So now let's move towards to the next theorem, which is what? Alternate segment theorem, number 7. Alternate segment theorem. Don't worry, you will soon get to understand all these theorems. I'm just giving you guys down so that when we are solving, we can easily what refer to anyone that you don't know. So number 7, alternate what? Segment theorem. Alternate segment theorem. Now, this states that the angle between a tangent and a chord, the angle between what? A tangent and a chord equals the angle in the opposite segment of the circle. Now, let's look at the diagram and see what it means. Okay? Okay, so we have a circle here. This is what this particular is talking about, a circle here. Then we have a triangle going like this. Then another one coming like this. Come on, correction. Then we have one like this. We have one like this. Yes. Then we have 90 degree here. 90 degree here. Thank you. Now, back again to the definition. Alternate segment theorem. The angle between a segment and a chord equals the angle in the opposite segment of what? Of the circle. Now, the angle between the tangent and the chord is equal to what? The angle in the opposite segment of the circle. Also, this particular side, if you're having 5 here, it is equal to what? This side was 5. Are you getting me? That is it. As you solve more questions, you get to what? To understand better. Okay, so I think that's basically everything you need to know on this particular topic. Yes, this is everything you need to know. Yes. So now let's now dive into what? Question proper. Exactly. So let's dive into what? Into solving questions. Yes. Enough of what? Of the theorems. Those are the theorems that you need for what? For your WAEC examination. Now, oh god, my is falling down. So now I'll be starting I'll be taking my question from the WAEC past question. Are you getting me? So I need you guys to pay attention. Are you getting me? Pay attention. All right, now let's begin. All right, so now our first question here is from the year 2020, and it says, so question 1. It says, or let me just say question 1A. It says, in the diagram, I don't call space, I can actually draw the diagram. Okay, I'll draw the diagram but make it small. So now in the diagram, this is the diagram here. This is the diagram here. This is the diagram like this. So here is E. According to the question, are you getting me? Here is E. Here is D. Here is C. Here is B. Here is what? Is 90 degree. Here is equal to here. And here is what? Is 108 degree. Now, they now said, in the diagram, O is the center of the what? Circle ABDE. ABCDE. I did not see A in the diagram, shout. I didn't say ABCDE. Maybe, well, they did not give us A sharp. So, in the diagram O is the center of the circle ABCDE. They now say that what? BC is what? Is equal to what? CD, which is what? These two things I showed you guys. And what? Angle BCD is what? Is 180 degree. They said you should find CDE. They said find what? Find the angle at what? At CDE. Now, when it's something like this, find CDE. It means that what? The angle is at D. So you get, that means the angle is here. So we have to find everything like this. Now, for us to find everything here, firstly, we need to find what is inside here. Are you getting me? So I call this one x. So when we get x now, we add it with this 90 degree. So you get to get what the angle at what CDE. So I'll write it here. So CDE, or I'll write like this: angle CDE is equal to what? Is equal to angle BDC is equal to what? Angle BDC plus 90 degree. That's the first thing you need to do. Yes, so we have to find what? We have to find this angle here, which is x, which is what? Angle, which is what? Angle, which is what? Angle BDC. Yes. Yes, BDC, or is it CDB? CDB. Except now BDC, or angle CDB, anyone? Angle BDC, anyone? Yes, we need to find that one, then add it to what? With 90 degrees to what? To get the angle there. Now, what do you do first of all? Now, looking at this triangle up here, which of the triangles have its both sides equal? So right now you need to also know what your triangle properties. Are you getting me? You need to know what your triangle properties. Now, let me just give you guys a breakdown on some triangle properties. Now, you see, there is only one triangle that's what has at least two of the sides equal, and that particular triangle is what? Is the isosceles triangle. Isosceles what? Oh, I got the spelling, sha. Isosceles triangle. No double L, just one L. Yes. So isosceles triangle. Let me write it. So the triangle that comes out every year in WAEC is what? Is the isosceles what? Triangle. It always comes out. So and this particular triangle, right? It has its both sides equal, and also the angle at both sides are equal. So you get, so now, and the angle in what? In this particular triangle is what? Is equal to 180 degree. Are you getting me? So how do we solve this question? How do you solve the question? You apply what? The isosceles triangle what? Formula, which is what? Angle, which is 180 is the angle what? Is the angles in what? Like the sum of the angles what? In this kind of triangle is equal to 180. So we have 180 is equal to what? Angle BDC, right? Yes, is equal to what? Angle BDC plus, or let me just call it, instead of me using angle BDC, I'll call it x. Let me call it x. Since they are both equal, it means that what we get here will be the same value that will be here. So if here is x, here will be what? Here will be x as well. Following what? The isosceles triangle what? Property. So now we have 180 is equal to what? X plus what? 1 plus 108. So the sum of these things here should give us what? 180. So now, what do we do to find our x? We collect like terms. So we have what? 180 minus what? 108 is equal to what? 2x. 180 minus 108 will give us what? 72 equals to what? 2x. Divide both sides by what? 72. You get here to be what? To be 36. So our x is equal to what? 36 degrees. Right? Now, following the formula again, this one, that to get your angle at CDE, you need to what? Add BDC with 90 degree. So since x is already 36 degree, which is what? Our BDC. What do we do next? We add 90 degree. So therefore, the angle at what? At the angle at what? At CDE is equal to what? 90 plus what? 36 degree, which gives you what? Which gives you 126 degrees, and that is what? Your final answer. So now, let me just recap again. Now, when you see a question like this, the first thing is that what you look at the triangle, you get, so that you can know what its property to use. But most times in WAEC always bring out what isosceles triangle, and in an isosceles triangle, both sides are equal, and what two of its angles are also equal, which is usually what the base angles here. So you get, they are always equal. So now, the first thing to do is to find the angles at these sides. So you get, before you now add it to 90 degree. And how do you find the angle at this side? You apply the formula, which is what sum of angles in an isosceles triangle is equal to 180, right? So you just do the sum of them, which is what I did here, which is what x plus x, because they are both equal, so we call them x. So x plus what the angle here. I get me. Then we'll get our x. After getting our x, we add this with 90 degree here. I hope you understand what I'm saying. Now let's go to question number 2. Yes, question number 2. So that's the first question on circle theorem. Come here, I'll write the circle theorem. Let me clean it. I'll write again. Circle theorem. Follow me carefully, because all this question I'm giving you now, on Wednesday, one of it will come out in your exam. Yes, one of it will come out. I'm very sure about that. So let me write one again. Circle theorem. Yes, circle theorem. 17 crazy times. All right, so now moving on towards question number 2. Now this one, I would like you guys to pay close attention. Are you getting me? Please pay very good attention to question 2. Now, what does it say? Question 2 says that in the diagram, BCDE is what? Is a circle with a center, which is A. They now said that what? BCD is what? Is 2x plus 40, right? They said again that what? BAD is this. They said that what again? All those angles which I've already written you already, so just take them down. They now said you should find your x and y. Now, this question is where we apply the theorems I give you guys initially. This is where you apply the theorems. This is what we call the circle theorem. Are you getting me? So I want you guys to pay very good attention. Now, what theorem are we meant to apply here first? The theorem we apply here is the first theorem that says that theorem that said that angle at the center. That said that the angle at the center of a circle is twice the angle at the circumference. It means that this one is equal to 2 times this one. The angle at the center of a circle is twice this. Are you getting me? That is the first thing to do. So that will give us 5x minus 35 is equal to 2 open bracket 2y minus 10. Yes, that is the first step. Are you getting me? That is the first step. Abi? Yes, now. Why am I saying 40 here? So, yes, that is the first step. Wait, I think I've mixed up the angles. Wait, this is C here. Angle BCD is this, yes. And then angle BED is what? 2y plus 10. Why are they putting minus here now? So this is wrong. 2y plus 10. Yes. So that's it. So there's a plus sign here. 2y plus 10. So now, let's now begin. Let's open up this bracket. So here we have 5x minus 35 is equal to 2 times 2 is 4. 4y, right? Plus 2 times 10 is 20. So now, after this, what do? We open up we collect like terms. So we have 5x minus 4y equals to 20 plus 35, which gives us 55, and this one gives us 5x minus 4y. We call this our equation 1. So what I'll do now is that I'll rub off these things and carry this one up because of space. You get me now? So let me rub this off. So just follow me carefully. You see what I'm applying the theorems. I'm applying the theorems carefully so that you get your final answer correctly. Yes. Question 1. Then now, look at it again. Now, let's now look at again at this diagram and ask ourselves what theorem again can we apply. You see that here and here are what are opposite angles in a quadrilateral. She gets sorry they fall under that theorem 4 that talks about opposite angles of a cyclic quadrilateral. Are you getting me? Right? So now the opposite angles of a cyclic quadrilateral add up to what? 180. So therefore the sum of these two is what? Is equal to 180. Remember that theorem 4, don't forget. So therefore what it means that what is that 2y plus 10 in brackets plus this one here, which is 2x plus what? Plus 40 is equal to what? 180 degree. So therefore 2y plus 2x plus 10 plus 40 is what? Is 50 is equal to what? 180 degree. This then gives us what? 2y plus what? 2x is equal to what? 180 degrees. Divide through by 2. We have what? Y plus x is equal to what? Sorry, minus 50 rather is equal to what? This one is equal to 130 degrees. So now divide through by 2. Here becomes y, here becomes x. 2 in 130 is what? We give us 65. If I'm not wrong, 65 degrees. Yes, 65 degrees. Then we call this what? Equation 2. Are you getting me? We call that equation 2. Now, we now have what? Equation 1 and equation 2. We can now what? We can now solve easily without what? Without stress. Are you getting me? We can now solve easily without stress. Right? Come in. Yes, we can also easily without stress. So here I can now say that I cannot say that yet y here, y should be equals to what? 65 minus x. Right? I'll now substitute this for y in equation 1. Right? Easy peasy. So I'll clean this one off. Let me now substitute it. So I'll be having here 5x minus 4. What did I get again, self? Minus 4, 65 minus what? Minus x, which is equal to what? 55. Right? So I'll be having here 5x minus 4 times 65 give us what? 4 times 65 will give us 260 minus 4 times minus x will give us what? Plus 4x, which is equal to what? 55. So now 5x minus, so I will now correct like them. This one will go here. So 5x now plus this 4x is equal to what? 55 plus what? If 260 leaves here, so that's it becomes plus 260. Are you getting me? So now here becomes what? 9x is equal to what is 55 plus 260? That gives us what? 315 degrees. Divide both sides by 9. Our x is equal to 35 degrees. Right? So now we've gotten our x to 35 degrees. So we will now substitute this x now back into equation 2. So now, and what is our equation 2 again? So now we've gotten our x now. What is our equation 2? Our equation 2 is what? Is giving us what? Y plus x is equal to what? Is equal to 65 degrees. So now if x now is 35, so therefore y plus 35 is equal to 65. And then y is equal to what? 65 minus 35. So therefore y is equal to what? 30 degrees. So therefore our final answer is that what? X is what? Is 30 degree, and what? Our y is what? Is x is what? Is 35, and our y is what? Is 30 degrees. That is the final answer. Are you getting me? So, okay, I think that's all. Yes, that's all. So now let's move on to question number 3. I hope you understand it. Please, if you don't understand, please do well to ask questions so that I can quickly correct you. So question 3 now, still moving on. Please pay attention, because of we are going to be using the theorem. See the way we use it now. This one I will use theorem 1 and theorem 4. Simple. And we're able to solve it. Now, this question 3. Coming. Question 3. Now, question 3 says, in the diagram, O is the center of the circle. Now, question 3, there is a diagram like this. O, sorry, there's a circle. Yes. Now, this place is called O. So now, O is the center of what? Of this circle. Then I said, of the circle X, Y, Z. Now, according to the diagram, we have a shape like this. We have a shape like this, right? We have something like this, yes. Then we have something like this in the shape. Okay? Then they now said that what? The circle is what? Is X, Y, and then Z. Right? X, Y, and Z. They now said, in the diagram, O is the center of the circle X, Y, Z. Right? Angle ZXO. ZXO. ZXO means that what? There's an angle here. You get me now? There is an angle here, which is what? Which is equal to what? Which is equal to 34 degrees. Sorry, you. Yeah, now. Okay, Z is up. Sorry, Z is up. Z is up. So we have X, Y, and then Z. So angle ZXO, which means that's what the angle here is 34 degrees, right? And then what? Angle XOY. XOY. That means here is what? Is 146 degree. They now said find angle OYZ. Find angle OYZ. That means find the angle here. Call this one X. Now note, this one might look familiar, might make you look as if it is theorem 3, but no, it's not theorem 3. You don't use theorem 3 in this kind of question. The theorem in this kind of question is what? Is your theorem. Come in, let me check again. Okay, there's a line even joining itself. There's a line dividing it. Yes. Is your what? Is your theorem 3? If I'm mistaken. Yes, sorry, your theorem 2. Your theorem 2. That says that what? Angle in a semicircle. Now, but before you use that angle in a semicircle, yes. First of all, remember this one. If here is 146 degree, it means that here is half of this one. You get? Yes, always. You know, that one is simple. By now, you should use theorem 1. Once here is 146 degree, so 146 degree divided by 2 will give us the angle here. So angle XZY, so angle XZY is equal to what? Is equal to 146. Is equal to 146 divided by 2, which is what? 70. Let me just write it here. 146 divided by 2, which is what? 73 degrees. So now, to get the angle here, the angle at this point, or let me break it down for you guys so that you guys can understand it better. The angle at this point is the sum of these two angles. The sum of these two angles is equal to the angle at this point. That is the first thing. So the sum of these two angles. So angle ZXO, yes. So no, angle XZY, yes. Angle XZY is equal to what? Angle ZXO plus angle ZXO abi, yes, plus angle what? ZYO. Yes, angle ZYO. So the sum of these two will give us what? The angle at this point. I did not give you that theorem, so just add it to it. So now, since we know that what angle XZY is what? Is 73 degrees. 73 degrees. And angle ZXO is 34. We don't know our angle ZYO. What do? We collect like terms. So you get, so therefore angle ZYO is equal to what? 73 minus 34, which is equal to what? 33. No, 33. Come in my calculator quick. (73 minus 34 is 39. So that is the answer. So here is what? Is 39 degrees. Simple as ABC. Thank you so much. Wow, I'm very tired of question 3. So now let's go to question 4. Question 4 is a little bit, or let me skip question 4. Let me go to question 5. At least so that I can move faster, because honestly at this point in time I'm already drained, and this is my last video for you guys, so I want to make it powerful, especially for this kind of topic, circle theorem. You get, I want to make it powerful so that you guys can easily understand. All right, so now let's take question 4 now quickly. Let's take question 4. Question 4. I hope you understand question 3. If you don't understand, just play it again. It's simple. First of all, let me clean this myself. First of all, use angle at a center or at a point, then follow the remaining methods I give. Now this one, they said in the diagram, let me quickly draw the diagram for you guys. The last time I was able to draw it fast. So this is diagram here. We have this, we have this, we have this, and then we have what? This. So the now said that what? There's a triangle here, right? You see here is K. You see here is 80. You see here is what? Is 41. You see here is P. You see here is Q. You see here is R. You see here is S. They say not drawn to scale. So my answer is not drawn to scale. Oh yeah, now. They now said in the diagram above, P, Q, R, S are points on the same circle. P, Q, R, S are points on the same circle with the center K. KR is a bisector of a angle. Now, they said that what? KR is a bisector of angle SRQ. SRQ. So this one here, this KR is a bisector. Now, when you hear a bisector, it means that what? The other parts should be equal. That is what you need to know first. The answer that's what? RS, the answer that KSP is 41 degree. KSP is 41 degrees. And what? SKR. SKR is what? Is 80 degrees. Find SPQ. Sorry, they said find what? RQP. Question 3A says find what? Find what? RQP. That is what it says. Now, what do you do first before you go into what? Finding RQP? First of all, the sum of what? Angles in a triangle. The sum of what? Of angles in a triangle is what? Is equal to 180 degree. Now, that is the first thing to start from, because of we have a triangle, right? So we need to start with that triangle, right? Again, let me even outline this stuff for yourself. Well, they said find RQP. Find RQP, which is the angle here. To get the angle here, in fact, let me even, I'm coming. They said find RQP, right? To get RQP using theorem 4. So using theorem 4, we can easily say that's what it is what they are opposite angles what in the quadrilateral should get. So that'll be what I'll call here x, right? So it will be what? It will be I'm coming now. It will be angle RQP plus RSP plus angle RSP is equal to what? 180 degrees. What this means is that what? If you can get the full angle at this point, just subtract this from what? 180 will get the angle here. It's as simple as that. But now, we don't have the angle here inside this triangle, which is x. We don't have it, but we have the angle outside. And mind you, this is what? A triangle as well. So like this is a triangle. So now, remember what I said earlier? I said that what? The angles that always, the triangles that always come out in WAEC is what? Are always what? Are always isosceles triangle. So therefore, without even wasting time, says to be cracking our head, this is what an isosceles triangle. Are you getting me? So now, since here is 80 and here is x, it means that what? Here also is x, right? So now, what do you do next? We solve using what? Isosceles triangle formula. So now the sum of angles what in an isosceles triangle is what? Is 180. The sum of angles in an isosceles triangle is 180. So that equals to what? X plus 80. Right? That will give us what? 180 minus 80 equals to 2x. So therefore, 100 here is equal to what? 2x. Divide both sides by 2. We have here to be what? X is equal to what? 50 degrees. Can you see it now? So now it means that x is 50. So here is 50 and here is 50. Let me write it there. Here is 50 and what? Here is 50. So now, since here is 50 and here is 41, it means that what? Angle RSP now is what? Is 91. So let me clean this one up because of this one is for isosceles triangle. So you get that's the sum of what? Isosceles triangle. The sum of angles in what? An isosceles triangle. So now we've gotten here as 50 RB. Let's now find what? Our RSP. So now our angle RSP is equal to what? 90 plus 41. Sorry, is equal to 50. 50, yes. 50 plus what? Plus 41. 50 plus 41, which is what? Equal to? Which is equal to 91 what? Degree. Are you with me? 91 degree. So now, following again this formula, theorem 4 formula, since here is 91 degree, it means that what? Here is going to be what? Angle RQP plus what? 91 degree equals to 180 degree. That will give us what? Angle RQP to be what? 180 minus 91, which gives us what? I think 89 degrees. That is your answer. Simple as ABC. Let me confirm. Yes, 89 degree. Simple as ABC. You can see. Not too much talking. Just what? Straight to the point. So now, that is that on that. Now, let's move towards question number 4. All right, question 4 now. It's like WAEC brings out isosceles triangle and theorem 4 most times. Looking at it, theorem 4. So go and master theorem 4 well. It always comes out because now we've done 3 questions, okay, and 2 of them are what are as we've done 3 questions. 2 have used isosceles triangle and 2 have also used what? Theorem 4. 1 I've used theorem 1. No, 2 I've used theorem 1 already. Yes. So now question 4. Question 4. Let me see. Question 4, what do we have here? It says in the diagram ABCD is the circle O. Let me go and find the diagram for you guys. That is a 2024 question. Question 4. I'm busy for question 5. I did question 5. Oh. So we've done, wow, we've already done. Are you kidding me? So we've done 5 already. Oh, thank God. This is question 5, guys. Question 5, I beg. No mistake. Question 5. Question 5. And I was like thinking that we still have more questions to go. So question 5 says, I did not skip anyone, shall I didn't skip this one. I didn't skip this one. I did not skip this one. I didn't skip this one. So this is question, okay. Did I skip it? I don't skip it now. I did not skip it. Now, question 5, the last question for today. It says, in the diagram ABCD, it said in the diagram, our circle again, you can see, there's always what? A triangle inside a circle. Here is O. Yes. Let me put the O outside. So, they now say that what? In the diagram, A, B, C, D is what? Is a circle O. The quadratic OBCD is a rhombus. And a rhombus, all sides are what? Equal. Abi? Yes. They now said, such that ADO, the angle here, theta, is equal to what? OBA. Is equal to here. Are you getting me? ADO is equal to OBA, and they are both equal to Y. Sorry, I go and rush. So we'll call it Y. So here is Y. So they are both Y. So here is Y, and then here is Y. Right? They now said BAD, angle BAD is what? Is T. Find the value of T. They say you should find what? Find T. And what? Find Y. Then find angle ADC. He said find angle what? ADC. That means the angle at this point here. You should find it. So now, can you see again? We can easily what? Spot out theorem 1 here, which is this part. To get here now, you apply theorem 1. Right? To get here also, you apply theorem 4. When you get here, to get here, you apply theorem 4. Right? And these two now, that equal, is under what theorem? Think theorem 3. Yes, it's theorem 3. It's under theorem 3. So you can see that what all these theorems are very, very important. That's why I have to start with them first. It's under theorem 3. Very, very important. So guys, don't play with them at all. So now let's begin. He said find T. Find T. Find T. So find our T. To find T that is here. Here automatically is what? Is 2T. Take that. Here is 2T. Yes. Because of this place is always 2, like, wait to come in now. Let me go and check my theorem again. Let me check my theorem. Yes. Here is what? Is 2T. Yes, it's 2T. It's 2T. So the angle here, so since here is 2T, you know we are dealing with a rhombus. So therefore, all the angles, these two angles here, this one here too, will be what? Will be 2T as well. Yes, because of it's a rhombus under what? Property of rhombus. Are you getting me? Yes. Now, moving on. What do we have to do next to find our t? Opposite angles of a cyclic quadrilateral are supplementary. Because of the Roman property, that's why we have 2t here, right? So now we apply this theorem 4, which is what? These two, their sum giving us 180. So t plus 2t is equal to what? 180 degrees. 3t is equal to what? 180 degrees. Divide both sides by what? By 3. Our t becomes what? 60 degree. That's our t. So we can now what? Erase here to become 60, right? And here we erase it to become 120, right? So now, how do we get our y? Now, remember what I taught you guys in question 3, that I said that what? The sum of the angles here, is always equal to this one. Are you getting me? The sum of the angles here is always equal to this one. So therefore, to get our y, it becomes, I'll clean this one now. So now I'll put, to find y, we apply that other theorem that I don't write down for you guys, which is what? The angle at BAD is equal to what? The sum of this one, which is what? Is it OBC now? Let me see. Which is the angle at BAD is equal to what? The angle at BAD. Abi? Yes. The angle at BAD call itself. Yes, BAD, yes. The angle at BAD is equal to what? To ADO. Is equal to what? Angle ADO plus ABO. Sorry, plus OAB plus angle ADO is equals to what? OBA. Exactly. So angle ADO is equal to plus what? Angle OBA. So since this one is 60 degree, here we what? Y plus y. So now 60 is equal to what? 2y. Divide both sides by 2. Y is equal to what? 30 degrees. You can say that every theorem is what? Is important. So please guys, don't joke with it at all. Every what? Theorem is important. Now we've gotten what? We've gotten our y to be what? To be 30 degrees. Now, they now said that we should find angle what? ADC. Now let me break it down for you guys. Now let's take a breakdown at angle ADC now. Here's my, okay. Now we've gotten our t, what's our y for angle ADC now. Now to find angle ADC. To find angle ADC, what you need to find the angle, because of ADC, this ADC means that what? All the angle at this point too, both this one that is here and then this one. You get me? So you need to what? You need to add angle. So to get angle ADC is equal to what? The sum of what? Angle ADO, which is here, right? Plus what? This one that is here, which is what? ODB plus, let me clean here, plus what? Plus angle ODB, right? Which is what? ODB. Now, plus what again? Plus angle what? DBC. No. Plus angle what? BDC. Yes. Plus angle BDC. This is the formula for what? For finding angle ADC, right? But then let's come back to this rhombus because of after this angle, the remaining two angles are inside the rhombus. Now, in a rhombus, now let me just quickly read out property of a rhombus for you. Opposite angles in a rhombus are equal. So it means that if here is 120, here will be 120. Remember that time because of here was 2t, that's why here was 2t. So here is what? Is 120 as well. And if here is 120, here is 120, it means that the remaining two sides will be what? The remaining two sides will be 60 and what? 60. Because of the sum of angles because of the sum of the angles she gets, the sum of angles in what? In a rhombus must be what? Equal to 360. Are you getting me? The sum of angles what? In a rhombus must be equal to 360. So since here is already 120, automatically here will be 120. So to find the remaining sides, just do 360 minus the two of them sum. You get what? 120. Divide by 2, you get what? The angles here, because of the angle here must be equal to what? The angle here, and the sum of them must give you what? Must give you 360. All right, so now since here is 60 now, this full side is 60 and here is 30. So we just write 30 plus 60 be equals to what? 90 degree. So therefore the angle at ADC is equal to what? 90 degree. Now let me do a brief recap so I can understand it better. I believe you all understood that we got our T and our Y. Just the ADC that might give you what? Small problem. So let me quickly clean up the circle again. Let me clean up the circle for better understanding. Let me clean this one up. So I will make the circle bigger. Come around. I'll make the circle bigger so that you can understand it. Because of this is question 5, the last one, and then it can come out in your examination. Yes. So let's have it. We have this very big circle, right? We call here point O. No, so it's 2y. We call here point O, right? So come down, Abi. Yes, then this. It's no longer to scale again. No, that time I tried. Then we have here up. Oh god, that time I tried. Let me draw my circle again. Let me draw circle again. Let me draw my circle again. So we have our circle like this. This one should work. Then we have our point O here, right? So we have our first one drawn to this side, then this one down here, then this one drawn to this side, then this one down here. Yes, then we have this one from here coming here, then this one from here coming here. Yes. So here is what? Here's our A, here's our B, here's our C, here's our D, right? Then we have what? A dissection between them, right? Here is what? Our Y, which is already 30 degrees. Here is what? Our Y, which is already what? 30 degrees. Are you getting me? Here is our T, which is already what? Equal to 60 degrees. And here is what? Our 2T, which is equal to what? 120 degrees. And remember, opposite angles in the rhombus is what? Opposite angles in the rhombus are what? Are equal. So therefore, since here is 120, here to be what? 2t is equals to what? 120 degrees. Now, I now said that to get your what? Your angle ADC. ADC is what? Is the angle that is here, here, and here. I get me? That like the sum of the angles here and here will give you what? ADC, which is what? ADO. Yes, which is what? ADO, yes, plus ADO plus what? ODB plus D plus ODB plus plus BDC. Yes. And then we already know what our ADO to be 30 degrees. That's why we have it here first. Then we now went on to find what? Our angle here. And to find our angle here, I used the rhombus property. Because of angles in the rhombus angles in the rhombus is what is equal to the sum of angles in the rhombus is what is equal to 360. So here is x. Here, this place like this from here to here is what is x because that's the rhombus. So since here is what 120 and here is 120. So sum of angles now, let me do it here. So now sum of angles now in the rhombus is equal to 360. So therefore 120 plus 120 plus x is equal to what? To 360. Are you getting me? 120 plus 120 will give us what? Will give us 240. Are you getting me? And x plus x give us what? 2x equals to what? 360. Correct like times 2x is equal to what? 360 minus what? 120. Sorry, 360 minus what? 240. X becomes what? What is 360 minus 240 equals what? 120 divided by what? By 2. That'll give you what? 60 degree. So therefore x is 60 degrees. So here is going to be what? 60 degree. And if here is 60, here also is going to be what? 60 because of what? Angles in the opposite angles in the what? In the rhombus are what? Are equal. You get it now? So if here is 60, here is 60. And since here is already 60, 60 plus the initial 30 is just 90. You see now? It's very, very simple. So ladies and gentlemen, my dearest scholars, we've officially come to the end of what? Of this video and our class on what? Mathematics. That's been a long ride since the beginning of May. I hope you enjoyed it and I believe you learned a lot. Please go back and practice more questions on angles, on circle theorems rather, you get, because of you will surely see them what in your examination. And you can see the way we are using shapes properties as well. So go and master your shapes and angles because that will also come out in your exam and this one as well. Are you getting me? So if you have any more questions, do well to comment it, to drop it in the comment section. And also, we'll be having a special revision class on Tuesday evening. So if you are interested, kindly comment interested now so that you can be added in time. Are you getting me? So that can be added in time. Are you getting me? So that is it for you guys now. Thank you so much and God bless everybody. I'll see you guys in my next video. That should be for English or chemistry. Are you getting me? So do well to share the video with your friends, like, comment as well, and God bless you all. I wish you guys success in your examination, and then God will crown all your efforts to success in Jesus' name. Amen. Thank you so much. I remain justified, and I'll see you guys later. Bye.